This question here it says, find the roots of the following quadratic equations if they exist. We have these quadratic equations here. We have to find out roots for them. And we have to apply the method called completing a square. Now, what is this method completing a square? We'll learn in this video here. Now, this equation here, we have to solve this through completing the square method. Now, this method here, completing a square, can be done in two ways. First, we actually make some squares and try to find out roots for this equation. Second method is same, completing the square method, but without making squares. First, we'll study completing the square by actually making the squares. And after that, we will study same method, completing the square, but without making actual squares. Let's take this up first with making some squares. To do that, what we have to first look for is coefficient of x square should be a perfect square. Here we do not have 2 is not a perfect square. So what we can do, we can multiply this complete equation by 2, which will give me 4x square minus 14x plus 6 equals to 0. Now I have coefficient 4 for x square, which is a perfect square. Now, completing the square means the very first term, this here, we have to make a square. This is the square here. If I take this side as 2x, this will also be 2x, this will be 2x, this will be 2x. Area would be 2x whole square, which gives me 4x square. This is done. Next term is this, negative 14x. Negative 14x will not give me a square. So let's draw a rectangle for this, like this. This is negative here. We can take this side as 2x and this side is 7. So area here would be 2x into 7, 14x. Okay. Again, let's focus on this. Completing the square means we have this square and we have this rectangle. We have to put them together and make a square. This square and this rectangle, when combined together, they will give me a rectangle. But we have to look for a square. If I split this rectangle into two pieces, like this, this remains as it is, 2x, 2x, and this side here, I am splitting it into two halves, 7 over 2, 7 over 2. Okay. Now, let's take this rectangle and put this along with this square here. This is my square here, this is square, 2x, 2x. Let's take this rectangle and attach with this square like this. This is 7 over 2. This is 2x. Now let's take this rectangle and attach here. We have to flip this. 7 over 2 is this. This is 2x, goes in the bottom. These two rectangles now sitting with this square. But this figure is not a square. But what we are looking for is completing the square. This area here is empty. Let's borrow a square and put it here. This piece here, the red one, this is my borrowed square. And size for this would be 7 over 2. And this would be 7 over 2. 7 over 2, 7 over 2, 7 over 2, 7 over 2. Now if you see, this side here is 2x plus 7 over 2. this side here 2x plus 7 over 2, this side here 2x plus 7 over 2, this side here 2x plus 7 over 2. Now what we have done here is we have taken these two rectangles and this square, and we have borrowed one more square and made a big square. So we are actually following completing the square. Now let's go back to the question here. It says 4x squared minus 14x. This is 4x squared, and these two area of these two rectangles putting together, they will give you 14x. We have to take off these two areas from this area of the square. So the new area would be 2x minus this length gone, 2x minus this length gone. So from this square, this and this is gone. This is the borrowed piece. Let's take this off also. Area of this. So from this square, I have taken off this, this, and this. All three are gone. This is the new area here, which is 2x minus 7 over 2 whole square minus 7 over 2 whole square. This positive 6 is sitting idle there. Let's put it back into action. This is my new equation here. Now, if you solve this equation and get the values of x, those values would be the root for this quadratic equation. Let's solve this equation first. Get the roots. 2x minus 7 over 2 whole square minus 7 over 2 whole square plus 6 equals to 0. Let's solve this. This will be 2x minus 7 over 2 whole square minus 49 over 4 plus 6 equals to 0. So this will be 2x minus 7 over 2 whole square minus 49 plus 24 equals to 0. So this will be 2x minus 7 over 2 whole square minus 25 over 4 equals to 0. So this will be 2x minus 7 over 2 whole square equals to 25 over 4. So this will be 2x minus 7 over 2. This square goes this side, becomes root. So 2x minus 7 over 2 equals to 5 over 2, positive and negative. When anything comes out of root, it becomes positive, negative both. So 2x is equal to 5 over 2 plus 7 over 2, and 2x is equal to negative 5 over 2 plus 7 over 2. Solve this, this give you 12 over 2 means 6. So 2x equals to 6. So x would be 3. This one here, 2x is equal to 2 over 2 is 1. So x would be 1 over 2. So roots for this quadratic equation would be 3 and 1 over 2. That's the answer here. These are the roots for this quadratic equation. Now, same equation through completing the square method we have done by actually drawing squares. Same equation, same method, completing the square we can do without actually doing the squares. Now we will learn how to follow this method, completing a square without actually drawing the squares. Let's do that now. We know that quadratic equations can be written in the form of ax squared plus bx plus c equals to 0. Completing the square means if I write this equation in the format of x plus a whole square minus b whole square equals to 0, I can easily find out roots for this equation. Now, go back to this equation here. Let's divide this equation throughout by a. We have a here, coefficient of x squared. So ax squared divided by a plus bx divided by a plus c divided by a equals to 0 divided by a. So this becomes x squared plus bx over a, or write it as b over ax, same thing, plus c over a equals to 0. No change. Now, if I write this equation in this format here, x plus b over 2a whole square minus b over 2a whole square plus c over a equals to 0. Now you must be wondering, my equation was this, ax square plus bx plus c. I changed that to this one by dividing throughout by a. This gave me this. Now, this equation changed to this equation. Is this equation here and this equation here, are they equal? Let's try. This is a plus b whole square, so this will be a square plus b square, means b over 2a whole square, plus 2ab, 2 into x into b over 2a. X plus b over 2a whole square becomes this, a square plus b square plus 2ab, minus this here, b over 2a whole square plus c over a equals to 0. This and this can be cancelled. This is positive, this is negative. 2 cancelled. I'm back to x squared plus b over a x plus c over a equals to 0. This was my equation, x squared plus b over a x plus c over a equals to 0. I'm back to this equation, x squared plus b over a x plus c over a equals to 0. If I multiply this equation throughout by a, I'll be back to this equation. So this equation here or this equation here, both are same. They have been presented differently. Now this piece here, I will be using to convert this equation in this format. X plus a whole square minus b squared equals to 0. Let's see how to do that. I have this equation here where my a is 2, b is negative 7, and c is 3. The very first step, we have to divide this equation by a, means by 2. So this 2x squared divided by 2 minus 7x divided by 2 plus 3 divided by 2 equals to 0 over 2. This gives me x squared minus 7 over 2x plus 3 over 2 equals to 0. 7x over 2 or 7 over 2x, same thing. This is just the way of presentation. Now, this equation here and this equation here, x squared, b over ax, plus c over a equals to 0, equals to 0. Next step, x squared, I take it as x. So x squared, I take it as x. Here I have minus, so I take minus. Here I had plus, I have taken plus. Then 7 over 2, b is this, so this stays as it is. A became 2a, so this is 2, 2 into 2 will be 4. There is no x here, so I leave x square minus b over 2a whole square means 7 over 2a. A is 2, so this will be 4. 2 into 2 is 4. whole square plus 3 over 2 equals to 0. Now let's solve this. X minus 7 over 4 whole square minus, this will be 49 over 16 plus 3 over 2 equals to 0. X minus 7 over 4 whole square minus 49 over 16 plus 3 over 2. So this will be minus 49 plus 24 equals to 0. This is x minus 7 over 4 whole square minus 49 minus 24 gives you 25 over 16 equal to 0. X minus 7 over 4 whole square will be equal to 25 over 16. This negative 25 over 16 goes this side, becomes positive. X minus 7 over 4 will be equal to, this square goes this side, becomes root. This will be x minus 7 over 4 equals to, this 25 over 16 becomes positive negative 5 over 4, because negative 5 over 4 into negative 5 over 4 gives you 25 over 16. 5 over 4 into 5 over 4 also give you 25 over 16. That is why this is positive negative both. So x would be 5 over 4 plus 7 over 4, and x would be negative 5 over 4 plus 7 over 4. Now if you solve this, this will give you 12 over 4, which is 3. If you solve this, this will give you 2 over 4, which is 1 over 2. So now x is equal to 3 and x is equal to 1 over 2. So roots for this quadratic equation would be 3 and 1 over 2. Now you can see here the result is roots are 3 and 1 over 2. As I said in the beginning, if this equation here, a quadratic equation, which is this here, if I change to this format, x plus a whole square minus b square equals to 0, I can find out roots. Now, if you pay attention here, this piece, x minus 7 over 4 whole square, this is x plus negative 7 over 4 whole square, and this is 25 over 16, which is 5 over 4 whole square equals to 0. This piece here is this minus this piece here, 5 over 4 whole square, is this. When this equation converted to this piece here means x plus a whole square minus b square equals to 0, I could find out these roots here. Same happened here. This piece here, this is 2x plus negative 7 over 2 whole square minus this is 5 over 2 whole square equals to 0. X plus a whole square, this is here, x plus a whole square minus b square equals to 0. I could find out the roots, 3 comma 1 over 2. Same quadratic equation, same roots. I follow this method, drawing some squares. I get same roots. I follow this method without drawing squares. I get the same result. So this is up to us which method we go for. We draw some squares or we solve it without doing some squares. Alright, this equation here, we have to solve this through completing a square. As I said in the beginning, we can use both the methods. We actually draw the squares and then find the roots, or without actually drawing the roots, we can also find out the roots. So first I'll actually draw some squares for this equation here. As I said, this coefficient which goes with x squared should be a perfect square. So I can multiply this by 2. So this gives me 4x squared plus 2x minus 8 equals to 0. Now this term here 4 is a perfect square. Let's draw a square for 4x squared. This here, this is 2x, 2x. This is a square, all sides are equal. So area here would be 2x whole square, which is 4x squared. Okay, then plus I have to draw a rectangle for this because I cannot draw a square for 2x. This is a rectangle. This I'll keep 2x as it is equal to this square, and this side I'll keep 1. Now I have to add this rectangle and this square, and after adding this I should be getting a square because that's what this method says, completing a square. Now to do that, if I split this rectangle into 2 like this side remains as it is, 2x. This will become 1 half, 1 half. So from this rectangle I have two smaller rectangles, equal sized, 2 halves. Now this is my actual square in the beginning, 2x, 2x. Let's take this rectangle and put it next to this, like this. So this is 1 half, this is 2x. Let's take this, flip it, and put it here, like this. This is 1 half, this is 2x. Now this figure here, again I do not have a square, I need to have a square. Let's borrow this square and put it here. This will be 1 half, 1 half. This square, dimension of this would be 1 half, all the sides. Now if you look at this, I have this big square, all sides are equal, 2x plus 1 over 2, 2x plus 1 over 2, 2x plus 1 over 2, 2x plus 1 over 2. This is the new square, all sides equal, 2x plus 1 over 2, 2x plus 1 over 2, 2x plus 1 over 2, 2x plus 1 over 2. This is the big square here. I have completed the square, but this piece here is not mine. This is the borrowed piece. I will take this off. This will go off from here, which is 1 over 2, 1 over 2. So the new area would be this square minus this square. So 2x plus 1 over 2 whole square minus this square, which is 1 over 2 whole square. This negative 8 sitting idle here. Let's put this back into action. This is my new equation here. If I solve x, the values of x will be roots for this equation. Now let's solve this equation here. 2x plus 1 over 2 whole square minus 1 over 2 whole square minus 8 equals to 0. This will be 2x plus 1 over 2 whole square minus 1 over 4 minus 8 equals to 0. Whole square minus 32 equals to 0. So 2x plus 1 over 2 whole square minus 33 over 4 equals to 0. So this will be 2x plus 1 over 2 whole square equals to 33 over 4. 2x plus 1 over 2. This square goes this side, becomes root, square root. So 33 over 4. So this will be 2x plus 1 over 2 equals to plus minus. 33 cannot be broken, so I keep this inside the root. Root 4 gives me 2. So positive, negative, root 33 over 2. So 2x would be root 33 over 2 minus 1 over 2. And 2x would be minus 33 root over 2 minus 1 over 2. So, x would be root 33 minus 1 into 1 over 2. I can write this as negative 1 plus root 33 over 4 also. There's no harm in there. And this will be negative 33 root minus 1. So x would be, I can change this also, negative 1 negative root 33 over 2 into 1 over 2, which is negative 1 negative root 33 over 4. So roots of this equation would be negative plus root 33 over 4, negative minus root 33 over 4. That's the answer here. Now, as I said in the beginning, I can find the same answer following this method, completing the square, but without actually drawing the squares. Now we'll solve this equation by without actually drawing the squares. Let's do that now. This here is 2, B is 1, and C is negative 4. The very first step, we divide this equation by A. So 2x squared divided by 2 plus x over 2 minus 4 over 2 equals to 0. This becomes x squared plus 1 over 2x minus 4 over 2 equals to 0. Second step, this x squared, let's take it as x plus b over a, b is 1, a becomes 2a, means 2 into 2 is 4, leave this x square, minus b over 2a means 1 over 2a, a is 2, so 2 into 2 is 4, whole square minus 4 over 2 equals to 0. Now let's solve this. This is x plus 1 over 4 whole square minus 1 over 16 minus 4 over 2 equals to 0. X plus 1 over 4 whole square, this is 16 minus 1 minus 32 equals to 0. X plus 1 over 4 whole square minus 33 over 16 equals to 0. X plus 1 over 4 whole square equals to 33 over 16. X plus 1 over 4 equals to root 33 over 16. So x plus 1 over 4 is equal to 33 stays inside. So this would be root 33 over 16 would be plus minus 4. So this is plus minus 4. So x can be root 33 over 4 negative minus 1 over 4, and x can be root 33 over 4 minus 1 over 4. We solve this, you get negative 33 minus 1. We solve this, you get positive 33 minus 1. You can write this as minus 1 minus root 33 over 4, and this can be minus 1 plus root 33 over 4. You can leave it till here also, or if you want you can do this. Both are alright. So x will be negative 1 negative root 33 over 4. X will be negative 1 plus root 33 over 4. That's the answer here. This one here, let's divide this by 4. So this will be 4x squared by 4 plus 4 root 3x by 4 plus 3 over 4 equals to 0. So this gives me x squared plus root 3x plus 3 over 4 equals to 0. So x plus b over 2a, means root 3 over 2 minus b over 2a root 3 over 2 whole square plus 3 over 4 equals to 0. X plus root 3 over 2 whole square minus root 3 into root 3 gives you 3. 2 into 2 is 4 plus 3 over 4 equals to 0. This is gone. So x plus root 3 over 2 whole square equals to 0. X plus root 3 over 2 equals to 0. So x would be negative root 3 over 2. That's the answer here. This one here, let's divide this by a or 2 since a is 2 here. So this is 2x squared over 2 plus x over 2 plus 4 over 2 equals to 0. This is x squared plus x over 2 plus 4 over 2 equals to 0. So x squared plus 1 over 2x plus 2 equals to 0. So this will be x plus b over 2a means 1 over 2 into 2 is 4 whole square minus 1 over 4 whole square plus 2 equals to 0. X plus 1 over 4 whole square minus 1 over 16 plus 2 equals to 0. X plus 1 over 4 whole square minus 1 plus 8 equals to 0. So this will be x plus 1 over 4 whole square plus 7 over 16 equals to 0. Now x plus 1 over 4 whole square will be equal to negative 7 over 16. Now if you see negative 7 over 16 is less than 0. Now if you try to solve it, this will be root negative 7 over 16, which is not possible. So the moment you find any number in this format where this side is equal to any number which is less than 0, in that case, that quadratic equation will not have any real root. So I'll write no real root exists. This is not possible. All right, not possible. All right, all done.